Hey, hi all. Welcome back to BRR Knowledge Center. In this session, we talk about the differences between value types and reference types. So, as I mentioned, let me share a screenshot here for more understanding. So, as I mentioned in earlier classes, all value types are going to be stored in stack memory, and all reference types are referring this heap memory. So, if you look at this diagram, this is what the diagram I just let me share this. If you look at here, this is what my memory, right? So my memory basically, right, going to split into two types, stack and heap. Okay. So this is my memory. Okay. My memory is dividing into stack and heap. So the stack type basically contains value types and reference type and basically stores in heap. So when you look at the stack, right? So a variable of value type directly contains data. Like when I say like integer from int empid equal to 3387, that value type directly having data, while a variable of reference type, right, just stores the reference as I mentioned. Okay. So let me come back. So as you can see here, value type stores actual value. This is value type, right? This is again references here. So here in the heap memory, right? So only stores the reference here. So reference type here, it stores reference into here. It stores reference into here. So value type stores its actual value directly into the stack, while reference type only stores a reference here. Okay. The actual value is in heap memory. Therefore, it is also possible to have two or more variables of the same reference, right? That reference exactly the same value. That means let me tell you like I have a class wherein is that oh, okay. So I have a class where is a student, right? In the student, I have int empid, right? And something string emp name. These are some members have been defined inside of the student class. Okay. So to use this members or to access student class, we need to create instance like student obj1 equal to new of student, right? Similarly, I'm going to create student obj2 equal to new student. obj1 dot empid equal to 3387, right? And obj2 dot empid equal to 3388. So this reference is having a different value. This reference is having different value. So that's the reason I'm saying heap stores reference types, right? This basically stores value of reference type, but the address is stored in value type. That's the reason. Okay. So there is a possible to have two or more variables of a reference type that reference exactly the same value. Okay. So even though this is empid and empid is the same attribute you are referring from student class, but having different value. So I'm storing here reference type obj1 and obj2, right? It's it basically having 3388 and 3387, but the address is storing here. Okay. Even though that the reference type is right same, right? But the values are different. It is also possible to have two or more variables of a reference, right? That reference exactly the same value. Value types are typically created at compile time, right? And stored in a stack memory. This allocation on the stack provides efficient memory management and a quick access because direct value we can fetch it in the value type. Okay. When it comes to heap memory, which is managed by a garbage collector, this heap memory is managed by a garbage collector. Okay. Hence, reclaim unused objects and stack memory is not subject to garbage collection. Hence, directly we can retrieve it. But here we have different stages in the DC. It is basically claiming the unused object, and thereafter it will move to generations 0, generations 1, generations 2. And after that, it will claim unused objects, and then it will remove. where the stack memory is not subject to garbage collection, hence it is very faster. So reference type variables like here in the class student, okay, right? So are stored in distinct area of memory called heap. Okay, this memory region allows for flexible allocation and deallocation of object during runtime. When a reference type variable is no longer in use, it can mark for garbage collection. The garbage collector periodically identifies and releases a memory occupied by unreferenced objects, right? So GC comes for heap memory, but not for stack, right? Because they don't have any references here. They directly having value. You directly use stack memory variable and retrieve the value. Okay. So this is the difference between stack and heap. Stack stores value type directly, whereas reference type stores value in heap memory, but the address of reference variable stores in stack. Okay. So value type stores its value directly in the stack, and it is very faster when you retrieve it. While reference type only stores, right, reference here, but the value again stores in heap memory. Therefore, it is something have two or more variables of reference type that reference exactly the same value. Hence, you need to get the address from here, and then you need to get the value where two-step process here. And also it decides the cleaning process by GC, right? And whereas stack is not subject to GC, hence it is very fast. Okay, so let me move this. We talk about here, as you can see below, as you can see below, the value type stores its actual value directly into stack memory, while a reference type only stores reference here. That means in stack. Okay, the actual value is in heap memory. Therefore, it is also possible to have two or more variables of a reference type that refer exactly the same value. Okay. So value types basically stores direct values in stack memory, while a reference type only stores reference in stack, actual value is still in heap memory. Okay. So therefore, it is also possible to have more than one variable of reference type that reference exactly, right? Exactly same value. Okay. And and value types are value types are typically created at compile time and stored in stack memory. This allocation on the stack provides efficient memory management and quick access because it doesn't have any second step process to get the value to the values. It is important to highlight that stack memory is not accessible, right, by the GC. Unlike heap memory, which is managed by garbage collector, right, stack memory is not going to accessible by the GC. Okay, so unlike heap memory, which is managed by the GC to reclaim unused objects. The stack memory is not subject to the GC collection. Okay. Value types are typically created at compile time and stored in stack memory. This allocation on the stack provides efficient memory management and quick access to the values. It is important to note or highlight that stack memory is not accessible by GC, unlike heap memory, which is managed by GC to reclaim unused objects. Okay, so reference types, right, such as classes, interfaces, arrays, etc., right, stored in a distinct area of distinct area of memory called the heap. Okay, this memory region allows for flexible allocation and deallocation of object during runtime. That means this is not going to happen at compile time. This memory region, okay, allows for flexibility, allocation, and deallocation of objects during runtime. So value types are basically compile at compilation time. These are basically deallocates at runtime. When a reference types variables are no longer, like how it will do is when a reference variable is no longer used, right? It can be marked, right, for GC collection. So the GC garbage collector periodically identifies and releases these unused objects and ensuring efficient memory management within the heap. Okay. So GC periodically identifies and releases memory occupied by unreferenced variable objects, ensuring efficient memory management within the heap. Within the heap. This is about the differences of value type and reference type. Value types basically stores in stack directly, wherein it directly get the value. It is more quicker compared to heap memory because it doesn't have any reference. Also, this does not subject to garbage collection. When it comes to heap basically stores value here in heap memory, but reference store in stack memory, right? So as part of process, this is going to happen at compile time, but this heap memory allocating and deallocating is happening at runtime. When any object is not longer used, then it will mark as unreferenced and give a notification to garbage collector. Garbage collector periodically looks for these unused or unreferenced objects and it will release the memory. And that's how it is ensuring efficient memory management within the heap. Okay. So thanks for listening to this video and please subscribe this channel for more videos. Thank you.